How should curly with type inference figure out that this question mark here should be replaced with a type number? The way it'll work is that the new curly will make a type variable to stand for that question mark. So let's call the type variable t1. And that means that x here in the body of the function has type t1. Continuing on, 1 clearly has type num, and then this plus wants both of its sub-expressions to have type num so that it can be overall type num. And so in the process of making that happen, it'll have to decide t1 must stand for num. And that way, this function overall, if num goes in place of the question mark, which is what we decided for t1, then overall the function has type num arrow num. So the overall strategy is, when you see a question mark in the type checker, create a type variable instead. And then instead of just comparing a type to number, then we may need to install an equivalent inside a type variable. As another example, suppose we have this one where the programmer did not write a type for x, and the type checker for if makes sure that t has type bool. 1 is of type num, and then x is going to be some type variable, t1. And now the type checker needs to make sure that this is bool and that these two are the same type. That comparison will again force t1 equal to num so that the overall if expression can have type num. That means the overall function, of course, has type num arrow num again. Sometimes a programmer may write a question mark and there is no type that would make this work. And in that case, our type checker and type inferencer is still going to have to reject the program. In this case, for example, for the question mark, we make up a t1, and so in the test position of if, x has type t1, and 1 still has type number, and this x also still has type t1. But the type checker wants the test position here to have type boolean, and that will force it to decide that t1 is equal to bool. Meanwhile, it'll check that the then and else branches have the same type, which would try to force t1 to num. And so it's not going to work out. You can't make t1 be both bool and num, and that's why the type checker and type inference will have to reject this program. Here's another case. Sometimes we make up a type variable, like t1 for y, and then nothing forces it to be any particular type. So our type inference and type checker here will come up with a type something like t1 arrow t1 for the overall lambda. And that's really called a type schema. It stands for many possible solutions to this problem. It could be that t1 is num, in which case the type has the type overall is num arrow num, or t1 could be bool, in which case it's bool arrow bool. t1 could even be a function type, num arrow bool, in which case this overall function takes one of those functions and returns that same kind of function. So what our type checker will have to do in this case is not guess which one you meant, but just report t1 still in the final type.